faster than your SSD or hard disk. Does it make sense? So we use something called RAM disk. RAM disk. There are libraries using which you could try this RAM disk, which is still available today in different operating systems. So that's your optional homework. Try creating a RAM disk. So optional task. Coming back, so we have hierarchy of memories and interconnection network. So the network is connecting the processing element, your hardware. So your circuitry processing element could be a CPU, tensor processing unit, any other processing unit. Host or node. Host or node is a computer in a distributed system. So you have a connected system. In that one of them is a host. In those who have studied computer networks, you also know host is a PC, or your phone is also a host. Degree of parallelism, so number of processing units being used in a parallel algorithm. Degree of parallelism. Remote on the other side is separated by a computer network. So Gmail is in a Google. What they're calling is St. Olaf is a router station. So there are two separate networks. Local is, in contrast with remote, you're nearby. You may be on the same network or very close. Resource, any computation related resource, processor, RAM, it's a network, any kind of memory, anything helpful for computation. Protocol is a set of rules. Protocol means it's a set of rules. Protocol, so it could be a communication protocol, other kinds of protocols are there. Set of protocols. So you'll find IETF guidelines for different protocols. Internet Engineering Task Force. IETF protocol. They have protocol lists, protocol guidelines. So they create lots of protocols. Internet Engineering Task Force. There are different kinds of documents. One is called RFC, Request for Comments, RFC, Draft, Standards, Working Group Materials. Very many different kinds of materials. So start making yourself familiarizing with those things, like you'll find a chain of paper on HTTP, another chain of paper on FTP. So these things didn't come at once. People worked on each of these for years, if not decades. You'll find all reference documents, the updated version, you can chain of those there. For example, so this is on the TCP/IP track, and this is from 1981. Okay, now I'm going to see if we could find. So you read it up, and then we get reference to older one, 1122. That's communication layer of our internet host. And if you keep reading, so you get the later one updated by, and previous ones updates that. So if you keep going to the past, you get, okay, we now from 1991 we're in 1981. Even earlier, obsolete that 761. That's 1980. Transmission Control Protocol, that's Department of Defense, DoD. So for each of the protocol, you find many different documents like this. Whatever you work with, find the full chain, read it someday. If you really are into the field, you should know how all protocols work, including mail protocols, file transfer protocols. So everybody who develops a browser or any transmission over the internet, they study this in detail. Sequential computation you saw before, working on a single processor step by step. And if you're doing a lot of these, those are some sort of batch processing. Parallel, you're using multiprocessing element you wrote today. Scale. Scaling up or down. So it's order of magnitude. Scaling up means you're speeding it up, working at a greater scale. Robust. Even if you face challenge, you keep going, fault tolerant. So it still correctly works even after failure. So there are different levels of parallelism. Stand alone, working on a single machine without depending on a network. It may be connected to a network but not using it. So different level of parallelism. Processor level within a computer. So when you're working on multi-core, that's your processor level. Computer level, working on multiple processors or processing unit within the machine, distributed among different machines. So you have interactive, means you are asking user a question or user is doing some interaction to affect your processing. Batch processing is no interaction. For example, have anybody ever used installed operating system or any other software without a single prompt? You double click on it, everything is set up and it's ready. Have you ever done that? Try this. It has something like unattended installation or silent installation for any software you have ever installed, be it Windows, Linux, browsers, operating office, any other software. Look for unattended installation. That means you run it, it gets installed. It doesn't ask any questions. When will it ask questions? Maybe after installation or before beginning of the installation, one time. But for most, this unattended is no question at all. Take some defaults, leave others empty, complete the installation. No interaction at all. No interaction at all. That is why it's unattended. The unattended or silent installation. Because all those interactions takes time. And interactions may not be feasible if you're on a remote machine. If it stops, that's a problem. And you are very lucky because you install operating system very fast. Our operating system installations were 2.5 hours long, if not longer. Because you start and they need to stop us for what is the computer name. We give the computer name, they need to work for 30 minutes. And then it stops again. What is the time? We give it time. So there was no way to speed it up. It would stop after once in a while to take a new set of inputs. That is interaction, yes. Capture is interaction. So it wastes time. So it took them a very long time, over 10 years, to figure out that they could combine all the inputs together. Anything. Take all the required information as a configuration file and then work. Does it make sense? It's required for automation. Because you want to work in parallel and every instance asks you to activate your software, how would you parallelize? Or your trial making it. So it has to be automated. Or it should be one-time configuration. So try unattended installation of silent switch for systems. Okay, so interactive is you talk, BAT is no talking, we file all the work and then keep working. Example, if there are client server applications, when there is one client, multiple clients, one or more clients on one server. So you're serving something. It could be serving file, serving media, serving an IP address. We have done computer network courses. Anybody who did not? Do you have a Wi-Fi at home? Your device is connected to the Wi-Fi? Does the device have an IP address? How did it get its IP address? How did your device get an IP address? So you have an IP pool, you have a range of IP and one of the IP gets assigned. Who assigns the IP address and what protocol is used for that? DHCP, what does DHCP stand for? Okay. Then you have earned yourself another optional task. Go through all settings of your Wi-Fi. Open up your Wi-Fi settings, don't modify anything unless you're sure of it, but not the settings, all the terminal was mentioned there. Know how to use access that. Everybody can access your Wi-Fi router settings using phone or a browser. Everybody can? Okay, well. Why? Okay, so is there anyone who is unable to access the settings of your Wi-Fi router? You should have access, unless it's not your own Wi-Fi router. So, how do you access? Using a browser or phone app, right? Okay. Most. So, Wi-Fi routers on a machine. Did you know that? The PC running some mini Linux. Your Android phone is also running some mini Linux. Okay. So, let's start a bit advanced. So you may or may not wish to do. I'm showing you an example. Have you ever bought anything, any kind of shopping? You put everything inside one bag, it's easier to carry. If you order too many things at once, then it's easy for checkout. Even if ordering food panda, you're ordering lots of items from a single restaurant, you're paying at once, giving all the instruction at once, tips at once. If you pack things together, it saves time and overhead. Okay? If you have lots of pictures in your computer, every file has something called metadata. Metadata, that is data about data. What is the metadata about a picture? Size, resolution, which camera was taken, the GPS location, many things right there. So metadata has those things. Every program you run your computer has a header. Every executable file, every application file has a header, just like images, image file. Header is the beginning information about the file structure, what kind of executable is that. So there are some things. So one of them is called PE header. We're not going into that yet, but I'm showing you one optimization. That is, there is a version called BusyBox. BusyBox. in BusyBox, they have packed many, I think 50 or hundreds of programs together in one file. So all Linux terminal or command line program in one single executable file. How is that possible? Anybody know C++ or Java here? Or have you taken any command line value using your Python program? So you have run your program like this. So this is your program, and then you have passed something called value 1 and value 2, and you get, so if you run your program like 3 and 5, it will output 8. Can you do that in any programming language? Or have you ever done that, or at least know how it works? Okay, so this is the program name. You pass two different values. When running the program, it's not keyboard input. It's not keyboard input. No keyboard there. So you're passing as a parameter, which are called command line arguments, args, or arg, list of argument values, or arrays, or list, arg list, or bars. So you're passing parameter program. So what does the programs do when it runs? If it's a C++ or Java, it's like that. It's you have something like this. This is C language. In C language, you have something like this. You'll have int main, then you have int argc, and then argv. What does this mean? It means argument count, how many things are being supplied, and then we have argument values. So list of all values. What the operating system does is that it creates an array of these values, list of these values, and supplies here. It supplies two things, that is how many and what are the lists. If you have ever selected multiple files and then it zipped them, antivirus scanned them, add to playlist, then this thing happens. They created a list and then passed that list or array to the program. Three things get transferred. What is the program name? So this is the name, from, count, and list of values. In C++, this correct me if I'm wrong, because I've done this thing more than 2 decades back. It has something like this. It's like smarter array. That is, it knows its length. C++ arrays knows their length. There's no separate passing of the count. In Java, we have void main, and we have something like this, string args. So in Java, the array also knew the length of the array and the values. Okay, so in short, you're getting the program name and list of array. All of those are strings. You have to convert the string to numbers before computing. So what BusyBox does is, this is Aryan, and here I'm calling Aryan. At home, maybe he's being called as Freshco. Okay, it's the same person responding. Some other teacher in some other classroom is calling him by student ID number. It's the same person responding. Not exactly the same example, but this BusyBox has list of commands. So what it does is all these commands. So in those, it has 50 or hundreds of commands, one file. Whatever you call it by is going to behave like that. If you call it using, say, something called sort, hypothetically, it's going to behave as a sort program. Again, hypothetical example, not real. If you call it by a player, it will behave like a media player. There is no player here, but it will behave like that. So it's one single program based as 100 as program based on name. How does it know how to behave? It knows by the command line parameter. So if you say that, again, these are hypothetical examples. If you call it by sort, and 5 and 3 is gonna give you answer 3 and 5. Hypothetical, like this, if you call it like a sum, 5 and 3 is gonna give you 8. It's the same program behaving based on the name you call it by. Does it make sense? What is the benefit? It saves the time, size, because your router has very small amount of storage. If you have separate programs, you do duplication of some part of the program, which will take much more space, and maintaining all those versions. Is the idea okay? Excellent. Not just that, this is a powerful machine, right? Lots of power in here. 12 core! 3 gigahertz! 6 core, 12 logical core, 11 on cache 480 kb, level 2 is 7.5, level 3 is 18 MB. My first process didn't even have L3 cache. And my second computer processor was 60 megahertz. Not gigahertz, it's 60 mH. You're using what? 3000 megahertz. Our one is 60 megahertz. We did overclock that to 120 megahertz. Okay, this is a pretty fast computer. Anybody disagree? Very fast, right? All of you are witness that this machine is fast. Don't call it slow. Reading it forward, nothing special. It's all fast. Let's see how much disk space we have. Almost free. 400 GB free. In all writes, at least. There is no shortage of space. I'm going to create a file. Text file. T for tiny file. Has only one letter in it. It's called A. Okay? One file having. Oh, what is the size of this file? 1 byte. Not even kilobyte, it's 1 byte. Very small file. Okay? How many bytes do you have now? 2 bytes. Now? So, number of files, and that is number of bytes, right? Very tiny files. Only 2,000 of them. 2,000 bytes is equal to what? How much? 2 kilobytes. Anybody have large enough pen drive for that? You use pen drive, something for pen drive? Yeah, is that still in use today? No, these are not. Okay, so anybody who is having hearing difficulties, please turn on closed captioning CC, and I'll try to look towards you while talking because this is directional microphone. Okay, let's get that. Again, if you face difficulties in audio, these are not BAT files. Somewhat like that, these are plain text files. We have only 15,000 of them so far. 15,000 files. In total, how much space is that? 15,000 bytes or kilobytes. That's 50, even if they are 1 kilobyte each. So they take, again, the data content is 1 byte. But the disk space they take is up to 1 kilobyte. Why? They take a bit more space because the files are structured. So if you write your student ID on your copy, how much space does it take? Arguably one whole page, even if it's only 8 letters. Does it make sense? So there is the smallest unit that you can know. I thought it was fast. Intel inside. You could try this on AMD as well. They're very brilliant. Maybe the disk is slow, right? This must be slow. Because how many files there? 36,000, right? 36,000 kilobytes. How much is that? 36,000 kilobytes. That is 36 megabytes roughly. 36 megabytes. That's so huge for these artists. But they claim 3 Gbps transfer speed, right? And these hard disks probably have 100 Mbps to few hundred Mbps. So the whole thing should be taking less than 1 second. Working core, you're talking about the processor? Processor is very busy. For 1 kilobyte file. Very busy. All we're dealing with what? 36 megabytes of data. All of you use USB 3, right? USB 3 is also called super speed. USB 2 used to be called high speed. And USB 2 was 480 Mbps. So USB 3 should still be transferring more than 100 Mbps, or at minimum 60 Mbps, even if you have something wrong in your machine. Not this slow. Again, for another comparison, you're doing transfer from your machine to machine. Network is not involved. So this is not network speed. Your machine to machine is saying this. This is the fastest it can get. What's wrong in here is not the data part that is wrong. It's the metadata. It's queuing because this is a smart operating system. It is smartly trying to give you a preview of this percentage, this progress bar, and time remaining. Counting starts at the beginning. And more importantly, is looking up names of each file. So your data transfer is 26 bytes per second. So that is slower than a dial-up. In comparison, that's slower than 2G network. Does it make sense? Because you're asking all 60,000 files, their name, size, and calculating all those. This is your overhead. Lesson: if you're working with too many small files, do not process them separately for transfer. You have to transfer any data set involving a lot of files. Lot means say more than 50 or 100 or like that. Then do not copy individually or even 50 files. Before network transfer, you should group them together as one single file. On top of that, compress it. Why would you group it? Grouping is consolidating all files into one file. what will happen is not gonna query this file name size again and again. This slow on this super fast machine is gonna be an order of slower on your network. So this is your task. Try doing this on your machine. Once you're done with it, try copying this folder to your pen drive. It's not going to fill up your pen drive because it's very small size, right? They got scared already. So it's 70,000 now. That's 78 megabytes. So it's not going to fill up your pen drive. So try copying a folder containing 80,000 files to your pen drive, tiny file. It's going to take forever. Similarly, try uploading to your Google Drive, Dropbox, or anything else that your Box, Mega, anything that you use is going to take a lifetime. Lesson: never transfer too many files on the network separately. Combine them together as a solid file. I mean, console is a file adjacent together, no gaps. Treat it as one file. For example, probably some students used to do this, or even foreign students or people do that. They combine everyone's luggage together, documents together to do FedEx or TH together. Maybe if it doesn't have to be directly sent to the university, and then split up later. That's good for the network, because for network transfer, where were we? Okay. So how do you do that? On Linux world, you'll find something called tar.zz. It's called tar.zip. Tar has a very old connotations like tape archive, but we're not gonna focus on that. What it does is combines multiple files into a single file, and you're grouping all of them. And second is, on top of that, you're doing GNU zip. So it's like you're compressing. On Linux systems, you could try this. Even if you do zip, just zip, the normal zipping is also combining into one file and then compressing. It's somewhat similar. You could try zip, but there is some software I used to like that is 7-zip. Did anybody use 7-zip? If not, try this. And can we talk outside? During this, to solid archive. Solid archive, which saves a bit more space. Of course, has some bad side as well. Do you have 7-zip? I don't think so. Try 7-zip, but some Linux systems will require extra package to be able to unzip that. Okay. So this is developed by someone called Igor Pavlov. So we were using, I think, Windows XP or older Windows. We had lots of RAM that month, I think 8 gig or something. And then we told it to compress. And it said no memory. But we had memory. What went wrong? We had free memory, but 7-zip could not use that memory. How many free chairs, empty chairs do we have? Ignore the bags. I see 3, 4. Counting your own? 3. Okay, we have 3 free sets. Now, a group of free friends are coming in soon, and they want to sit together because they do better in exams if you just sit together. That's inspiration versus what I think. So, but we have prefix, they cannot use it because they are not side by side. So any memory allocation that happens It is array allocation. Array is by definition, by design, guaranteed to be adjacent in memory. So it has three separate sets, but it cannot create an array of size 3 because they're not adjacent. What happened is called memory fragmentation, and that was a significant problem of 32-bit system. On 64-bit system, they do some remapping, so that when I told Igor Pavlov that your software does not work, and he said, how many bits do you have? And then you're suffering from memory defragmentation. So then we use defragmentation for a RAM, which is sorting all the RAM blocks. Similarly, if you have 3 partitions and each of them have 100 gigabyte free, still cannot store a single 200 gigabyte file because you have this state fragmentation. Does this make sense? Now this array, they are side by side in the memory. That means you can hold large enough data side by side in the memory for sorting. Not just that, there's something called prefetch, right? When we're writing in the exam, what we do, we're writing one line, but in advance looking at next line from nearby sits, right? It's called prefetch. You read data ahead of time, so that it speeds up. Anybody who's doing recitation, they write, read one verse and then say one verse and read the next one. When you're counting money, you're counting one, but your hand is in the next note or currency. You're turning pages, you're looking at one page, your hand is in the next page. It's called prefetch. So if we have lots of data adjacent in memory, then we can do something called acceleration. In prefetching data, it's going to lead to speed up. Does this make sense? But if they are not adjacent, so if they're adjacent, they're cache friendly. You can prefetch and adjust your cache. But if it's not adjacent, it's not cache friendly because you're jumping around computer memory, it's going to be slower compared to that accelerated version. Does it make sense? So if your next quiz syllabus is from 3 different chapters in the book, it's going to slow down your preparation versus it's in the same chapter. Okay, so adjacent the memory is cache friendly, and sorting and other things usually require the data to fit in the memory. I have a 1 terabyte data set. If I give it to you, can you sort it at home and give it back to me next class? 1 terabyte size array saved on disk. Can you sort it and bring it back next day? I have one file containing 1 terabyte of integer numbers, random integer numbers. You sort them in ascending order, small to large, and bring it back to the next class. Can you do that? Can you do that? First, you have to create the array in memory, right? So all of you have 1 terabyte RAM. You don't? Now how are you going to sort? But 1 terabyte is not sufficient because you need your operating system there as well. And maybe you need more than 2 tera for 1 tera for input and 1 tera for output. Input and output also takes memory. Remember that. We learned it in the hard way in cumulative programming. Input and output also takes memory. Okay, going back. BRAC is a bioinformatics related program which matches a known sequence with other sequence. You could do this in parallel. Any work that you could do easily parallelized is called embarrassingly parallel. There is Google MapReduce framework. It has some portion which can be done in parallel. So that MapReduce is also highly parallelizable. So that's in Google's early days, they used to do that. High performance computing worked for a short time, and that could be minutes and days for delivering large amount of computation. A related term is how high throughput computing, and they have separate software stack a bit of that, but it works for longer time, months or days. So processor level, computer level, distributed level with C, cycle scavenging. Your computer will run, but you are going to use the free time, free CPU cycles, idle CPU cycles for your computation. So Satai at home used to be what everybody around the world installs it. They would go on their regular life. They don't even know it's there or realize that. But it's whenever you have you seen the concept of screensaver? Or your phone turns off your screen, or your PC laptop turns off your screen, it was not used for some time, right? It detects idle time. Similarly, the software also checks how much CPU is free, then it starts using those. If you start using your machine more, then they stop their reduce their activity, or if you're using it too much, they stop their activity. Does it make sense? That's called cycle scavenging. It's like shower কাছ থেকে 2 টাকা করে নিয়ে আসে, অনেকটা এরকম. So you have small CPU cycles every now and then from multiple machines, global scale, you do that. B-Wolf cluster, this is going to come back again. B-Wolf cluster, a collection of network off-the-shelf computer. That means ready-made computers. These are not special purpose most of the time. So off-the-shelf, some ready-made computer, but you combine it together for solving large problems. Nodes, every machine is a node, every PC is a node. We have something called head node and worker node. Head node, don't get confused. Head node is not a controlling node, it's not the leader node. Head node is just the gateway, it's called login node. The machine which you use to access. The head node is not a leader node, it's just a login node. You log into a head node, you do a small simulation, you do a small test of your huge program, and then from there, you assign this task or schedule this task to be run on the worker nodes who does actual work. The head node is an average machine, maybe a little bit powerful for the tests, but worker nodes, they get the work done. Head node is not the boss, it's just the login, it's just the gateway. Does it make sense? Head node is not the head. Excellent. Clusters, a group of computers, rack mounted. Do you have a bookshelf or have you seen one? A shelf. Rack is like those shelf. Rack mounted means machines in miniature size like a briefcase or books. They get mounted. On computer labs you have the mini rack. It's composed of 6U. It's a mini rack, small size, and there are also racks which are floor height. That is also possible. So that's in those racks you put in additional machines. The St. Olaf radar station has their own clusters, 3 of them, and they have their own configuration. Okay. Next part, data parallelism. If you have a same program is run on different part of the data set, that's data parallelism. Different algorithms run in parallel, that's task parallelism. Different tasks running in parallel. You've seen that embarrassing because if it's you can run it with little effort in huge scale, that's embarrassing. That genome comparison is one. Have you done graphics course? We have done Mandelbrot. No, Mandelbrot? Computer generated graphics? You have not done that? Do this someday, okay? Noisy Mandelbrot. So, these are not natural images, these are computer generated using some formula, okay? This is Mandelbrot, you generate that. So you generate images like this. You're approximating patterns in nature or other people's design. So you're independently calculating pixels, you could do this in massively parallel way. Some parameterized, so you're varying, say, your virtual plants, or virtual device, even virus or bots or game characters, if every of them will start from a random parameter, so if they have different colors, different sizes, different locations, if you could do that, you could do that in embracing parallel world. If you could simulate a solar system like that, there are multiple algorithms for solar system. It's called N-body problem. N-body problem, you saw that in lecture 1. Satayafam, we talked about that. And the seismic, the St. Olaf rudder, they have increasingly used parallel computation. And what they've done, in short, again, you read up the details. First, running on a faster computer, their speed up was 4 times. Previously, they took 4 hours, now they take 1 hour. They modified and made it further, parallelizing the matrix processing. So now they are working on 34 processor computer, and they have 15 times speed up. So total 4 and 15 means 60 times speed up. So previously their program used to take 4 hours, now it takes 4 minutes. That's not the end of the story. Now they split up the data set and automated everything. And previously what it used to take 6 weeks, that now takes 1 week with 4 times the data set. So that's 24 weeks versus 1 week. So 24 times speed up. Okay. Now this speeding up, these have different formulas. So if a sequential algorithm takes 10 minutes of compute time and a parallel program takes 2 minutes, that's a 5-fold speed up, 5 times 5-fold speed up. So this will depend on what part of the problem can be parallelized and what part cannot be, and the overhead in communication and other overheads. So there will be synchronization delays if we have to wait for another parallel process to synchronize the results. And some part could be sequential, which cannot be parallelized. So rarely you get much more speed up. Normally that doesn't happen. Normally if you use 8 times the resources, you might get 5 times the speed up if the problem is parallelized. It's not the more resources you throw it in, it gets that speedier. It does not. Okay, there is something called Amdahl's law. You keep getting this in different tutorials. This estimate the speed up. Estimate the speed up based on what part of the program is parallel and what part of the program is sequential. So for one problem, say if speed up is, this is the formula, the speed up is going to be less than or equal to this. What is this P sigma and N? P sigma is part of the sequential program that can be parallelized, and how many processes will be used. Okay, so try this math with some values. They haven't worked in example. So do I need to go through this example? Put in the values and calculate at home. Try for different values. This is Amdahl's overall speed up. Yes, it is limited by that. But this is your estimate. You're calculating how much is theoretically possible based on Amdahl's law. So it turns out that using 4 processes you are getting only 3 times because there is a non-parallelizable part. Okay, so do this, read this side. Okay, and they explain why this is true. You go through that. Scalability and Gustafson versus law. The ability of a program to retain its desirable properties as the size or computation increase. So what if you have more processors? Will Amdahl law, how it will predict the speed ups? So you're putting in more and more processors. Will it keep getting faster? So even if you put in a lot of processors, there will be limitations. You'll get a theoretical max. No matter how many processors you throw in, it will have certain speed up, but you'll have some other benefit. You get the availability. If more things are there, even if some part go wrong, other part will be performing well. So you will get more available, more reliable. So go through the laws and try values, different values, and go through the explanations. So different limitations are there. So you get another formula for scale speed up. What challenges are there in short? So I'll go through this. And one thing is you have studied in maybe in database course and operating system course, there is something called lock. Some part cannot be parallelized, like that bank account transactions. So that's why for this you need some coordination. So the locking block, you need resources. Two program cannot use same microphone at once unless you want to share the audio. So there will be two program wants to write one single file at the same time. You have to do it by part, something like that. So there are some conditions holding up and exclusion. Okay. Now everybody familiar with merge sort? So let's see, merge sort, you're splitting up the array and trying to keep further splitting up it recursively. Once you're down to one element, you stop and sort, done. Then you merge and put the right things in right place. Same things happen repeatedly and you get your sorted array. Do you remember merge sort? Excellent. These files are in the course folder, all the links are there. There is a parallel version by Zaid Humayun. Do not get confused by the Rust code, it's just for fun. If you are, this sounds different language, skip the first box, look at the second box. This is C++, which will look more like your C, C++, Java. Okay, so look at this. What they're doing, splitting up the array, copying and swapping. The parallel version. If this is non-parallel version, at bottom you'll get the parallel version. What's happening is they're creating thread. It means left part of the array is going to another thread, right part of the array is going to another thread. So two thread processing data in parallel. That's the parallel is basic version. This std means standard library of C++. In different programming language, they'll have the library. This vector means it's a resizable smart array of C++. It's just a list of integer numbers. So don't get scared by vector. It means a smart array or list. This thread, except for your no thread, and after sorting left and right, you join to synchronize. Okay, and then you move the data. That's the basic version of parallel sort. Now your task is to read these papers. Your next quiz will be on parallel merge sort. The quiz will have two parts. One is no code and another is some code. So first read a paper. This paper explains how parallel merge sort is designed by Christopher Zelenka, and they compare different performance, how they did their pseudocode. I expect you to remember the pseudocode, not the code. Again, if there is any coding for first part, no code. You go through the whole thing, get some idea how they're doing it. Second, there is a second paper, and they also discuss pseudocode, how it's working, how parallel version might split up its work, and how things should go. Okay, pictorial step by step. Do I need to go through these step by step? Visual, you have done algorithm course, you know that. Now, same concept explained in video, 3 minutes 37 seconds. Next, if you want to implement in this Java, there's a simple library call, you could try that, and that's again less than 2-minute video. Watch that, that's part 1. Second part, go into detail and it's coding. You focus on part 1 first, and then you move first coding. In Carnegie Mellon University, they have a library of parallel algorithms. This is for your reading, next reading. So this is not part of the next quiz directly, but for next part lectures, you can use this for reference, parallel algorithms, different design of parallel algorithms. Does it make sense? So your quiz key is on, this parallel merge sort only. Okay? Any question on that? So is part 1 is pseudocode only. For part 2, that might include coding. Okay? Yes. I'm hoping next Sunday. We have something on next Sunday? This is merge sort. Okay. Let me even this up. What are you scared by? Are you scared by the pseudocode or are you scared by the code? Think scariest version of it. Problem. Okay. In a scale of 1 to 10, say how big of a problem is this? Hardest code. 7. Excellent. So your part 1 will have 75% weight, and this is 25%. So if the quiz is on 10 marks, your 7.5 marks will be coming from pseudocode, and 2.5 will be coming from code. So not even going on 7. I take this 7 as 7.5. Okay? Does this solve your problem? Okay. No, then you have a dedicated third quiz on coding. Okay, any question? Online Vito? Yes. Pseudocode 75%. All right. Thank you for coming in and spending time. Allah bless our